Today we're going to look at angle of elevation and angle of depression. We're going to start with angle of elevation. So this says when looking up to an object. So a real key here is you need to figure out where the person is or the animal or whatever it is that has a line of sight. So here we have a person, and the angle of elevation is formed by an observer's line of sight and a horizontal line. So from this person, the line of sight is from their eyes up to the lighthouse, and then the horizontal line that they're referring to would be from the person over to the lighthouse. So it's really important just to draw these out and think through where the elevation is, where the line of sight is, and then how far you are away from the base of whatever they're looking at. We'll go ahead and go through an example. So the first one says, Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So this is our picture up here, but we're going to go ahead and draw a picture again. You're going to want to draw diagrams for all of these because it will make it so much more helpful. So they tell us here that Casey is 6 feet tall. And then there's a lighthouse, and the lighthouse goes up to here, and the lighthouse is a total of 84 feet tall. So if he sights the top of the lighthouse, this is our line of sight right here, and the elevation, or the angle of elevation, is 58 degrees. So again, our angle of elevation is formed by the observer's line of sight, which is this line, and a horizontal line. So this is going to be what we are solving for, because it says how far is he standing from the base of the lighthouse. So this distance would be the same as this distance down here, standing over to the lighthouse. Our angle of elevation is 58 degrees, and now we're ready to solve. So if we're solving for x, oh wait, we have to do one more thing. If we have this total distance of 84, if we subtract the 6, that gives us 78, and that means that this piece right here from this line of sight up to the top of the lighthouse is 78. So that gives us the right triangle that we're going to deal with here. We think about opposite over adjacent, so that means that we're going to be using tangent. So we have tangent 58 degrees is equal to 78, which is our opposite, over our adjacent, which is x. And now we want to solve for x. So remember, we multiply both sides by x. These cancel, so that gives us x times the tangent of 58 degrees is equal to 78. We're going to divide both sides by tangent 58. These are going to cancel, and so this leaves us with 78 divided by tangent 58, which is 48.7 feet. For the next question, we have the angle of elevation from a kicker's foot on a football field to the top of the goal post is 17 degrees. So the line of sight is not always coming from a spot that's up off the ground. Sometimes it's on the ground. So in this case, we have our soccer player, and his foot is where we're going to start everything. So his foot is here, the goal post is right here. And it says that the angle of elevation from the kicker's foot up to the goalpost is our 17 degrees. So this would be 17 degrees right here. He's standing 131 feet from the base of the goalpost. So this is 131. And then the question is, how tall is the goalpost? So that's going to be x. So again, we think through what trig function we need to use. We have our right angle right here, so this is opposite over adjacent. So it's tangent 17 degrees is equal to x over 131. And we're going to solve for x, and you should end up getting x is equal to tangent 17. Make sure you put parentheses around that 17 if you multiply the 131 by it on the right-hand side. Our answer then is 40.1 feet. All right, go ahead and work out number 3 and number 4. Pause the video, and then we'll check our answers. Okay, these are the answers for 3 and 4. And you just want to think through, the slide is right here. This is the vertical height of the slide. The mom is standing here. And on this one, the dog is here looking up at the cat in the tree. So this is going to be 5 feet is from the dog to the base of the tree, the cat 16 feet up. Our angle of elevation is what we're solving for, so we're going to use an inverse trig function to find the missing angle. Okay, flip the paper over, and then we have the angle of depression. So this one's a little bit more complicated, but we just really need to get our bearings on where everything is and exactly what we're looking for. So when looking down to an object, that's the angle of depression. So you think D for down and D for angle of depression. It's formed by an observer's line of sight. So here we have a lifeguard, and the lifeguard's looking down at a swimmer. And the angle of depression is formed by that line of sight and a horizontal line. So our horizontal line, though, is up here where the lifeguard's eyes are. So this is our angle of depression. The neat thing is that the angle of depression is congruent to the angle of elevation because they're alternate interior angles. So if I think about these two lines as being parallel lines, this angle right here is going to be congruent to this one. And this is the angle of elevation because as the swimmer looks up to the lifeguard, we have the line of sight and then the horizontal line, and this is the angle that we end up with. So these two are congruent. This first example is just building off of the diagram that we had here. So we have a lifeguard sitting on the platform, the lifeguard's up here, and looking down at a swimmer in the water. Swimmer's right here, and the lifeguard's line of sight is 8 feet above the ground. So we're 8 feet above the ground, and the angle of depression to the swimmer is 18 degrees. So that means angle of depression, we're going to go back to our definition, it's the line of sight and the horizontal line that's going out. So here this would be 18 degrees. And the question is, how far away is the swimmer from the lifeguard? And we're thinking like the lifeguard stand here. So this is going to be X. Now if this is 18 degrees, then that means that this is also 18 degrees. So we can set up our triangle here, and we just want to think through what function we need. So we've got opposite over adjacent, which is going to be tangent again. So tangent 18 degrees is equal to 8 over x. We're going to solve for x by multiplying both sides by x. Just take a second and finish that, and your answer should be x is equal to 24.6 feet. Now you could have also used this triangle right here if you'd like. This is a right angle. If that's 18 degrees, we know that this over here is 8, and then this x would be right here. So you could look at that, but more traditionally we kind of come down and use the angle of elevation. Okay, so that was number 5. Then number 6, we have a pilot and is in a helicopter. So the helicopter's up here, spots a landing pad below, which is right here. If the angle of depression is 73 degrees, so here I've got my line of sight and the horizontal line that's heading over, so that's going to be 73 degrees. And the horizontal distance to the pad is 1,200 feet. So that means if I come down from the helicopter and go over, I'm looking at 1,200 feet right here. The question is, what's the altitude of the helicopter? That's going to be x. So this is 73 degrees because we have congruent angles right here, and then we just want to think through our trig function. Our right angle's there, so we have opposite over adjacent, so this is tan 73 degrees is equal to x divided by 1,200. Okay, and multiply both sides by 1,200, and we end up getting x is equal to 3,925 feet. For number 7, I'm going to help you draw the diagram and then have you finish the problem on your own. So we have building A is 480 feet tall. So we're going to draw building A, we're going to label it and put 480. Building B is going to be over here, and that is 654 feet tall. The angle of depression from the top of building B to the top of building A is 42 degrees. So our line of sight's going from B to A. We're going to use our line of sight and the horizontal line going across. So this would be 42 degrees. How far apart are the buildings? So this would be the distance right here, and that's going to be X. This is my 90-degree angle. If this is 40 degrees, then this is 42 degrees. And then I need to figure out what this piece is right there. So if I take 654, that's this total, subtract 480, that gives me 174. And so now I'm ready with a right triangle to set up my trig function. So I've got opposite and adjacent again. So this is going to be tangent 42 degrees is equal to 174 divided by x. You're going to solve for x there, and you can take a moment to do that. Wait, I wasn't going to set that up for you. All right, well, I set it up for you. So go ahead and finish it off, and then go ahead and do number 8. We'll pause the video, and then we'll check our answers. All right, so there are your answers. For number 8, we've got Zach standing at the top of a lookout tower, which would be here, spots a water fountain below, which would be right there. If the lookout tower is 75 feet tall and the angle of depression is 28 feet, so our line of sight, there's my horizontal line. What's the horizontal distance between Zach and the water fountain? So if that is 28, then this is 28, alternate interior angles. You set it up, and you should have gotten 141 feet. All right, so that concludes the notes for angle of elevation and angle of depression.